All right, we're going to look at Ohm's law and series and parallel circuits. That's what we're looking at next. Okay, so Ohm's law, we've already discussed a little bit. The relationship between voltage, current, and resistance in a circuit. And we talked about how current is, how resistance was defined as voltage divided by current. So this can be turned around to current is voltage divided by resistance. And this is often the way you're going to use it in class because it's easy to give voltage, that's a battery that's set. It's easy to give resistance, that is a physical device that is set. So current is the thing we don't know. Okay, so when we can use Ohm's law though in many different ways. And so it's often written as V equals I times R. That's the easiest way to write it. But it could be I equals V over R, or R equals V over I. And one of the ways to get those, students show me, is a triangle. And you put V and I and R. And the idea is if you cover up one of those, the equation will appear for you. So if I cover up V, then I'm left with I next to R. So that gives me V equals I times R. If I cover up the I, then I would get V over R. That's this one. If I cover up the R, I would get V over I. So anyway, so students showed me this. It's pretty cool way to remember the circuits. So if I have a 10-volt battery and a 2 ohm resistor, how much current will flow in a circuit? So 10 volt battery, 2 ohm resistor. That's going to give me 5 amps of current, right? So voltage over ohms, volts over ohms gives amps. So what is a circuit? A circuit is a closed path along which electrons can flow. And when it's a closed circuit, then we want a continuous flow. So there can't be any gaps, no open electric switches. Now, sometimes the resistance is provided by a light bulb. A light bulb actually has 2 contacts. So the electricity has to go in one way and out the other, or vice versa. But it's got to have 2 contacts because it has to complete the circuit. So when you screw it in, the screw threads actually are one of the contacts. It's called the screw thread contact. So electricity goes in from the base that you're screwing into. The other thing is that at the very tip of the light bulb, there's another contact point that's called the electrical foot contact. And that's where the rest of the electricity would travel. Okay, so electricity goes in through the filament, back out, perhaps through the foot. Okay, so here's that circuit we were looking at a minute ago. The light bulb is giving the resistance. And so what happens is that energy is used in the light bulb. It's converted from electrical energy into heat energy and light energy, right? Radiant energy. Okay, so anyway, so the light bulb is offering resistance. Okay, let's look at some different kinds of circuits. So you need to be able to handle a series circuit and parallel circuits. Series circuit has, for instance, this is 3 light bulbs in a row. Okay, and there's only one wire through the whole thing, one loop. Parallel circuits have 3 light bulbs, for instance, side by side, and they have parallel branches of the circuit. And so what happens is electricity can go in different directions through this. So there are different loops or branches to the circuit. Okay, so let's go look at each one of these. So let's look at series circuits first. Those are the easiest. Series have just a single pathway for electron flow. If you make a break anywhere in the path, then you have an open circuit. So here's a switch here, and you can see that it's pulled upwards, and all the light bulbs are off because no current can flow when that switch is open. If a switch is closed, that's good, and that allows electricity to flow. Now, one of the tricks to a series circuit is that the total resistance will add up. So the more devices you put in, then more resistance means less current. Okay, so since V equals I times R, then if the resistance goes up, the current has to go down for a constant voltage. Okay, so step 1, you add the resistors for a total or equivalent resistance. Step 2, you figure out the current. Oops, it says in each branch. Figure out the current. Let me change that. Using Ohm's law. Okay, so determine the current in the circuit using Ohm's law. All right, and so we use I is V over R total. Okay, so let's say we've got these light bulbs here, and let's say this is a 2 ohm and another 2 ohm, and we'll make this one 8 ohms. And we'll make this a 12-volt battery. Okay, so what's going to happen? Well, let's add up the resistors first, right? So the total resistance is going to be R1 plus R2 plus R3. And if you got more resistors, of course, you would just keep adding. So we'd have 2 plus 2 plus 8, which does make 12 ohms, as a matter of fact. Okay, then we're going to use Ohm's law to find the current. So we're going to take the voltage that's driving this, we're going to divide by the total resistance. So we're going to get 12 volts over 12 ohms, and that is just equal to 1 amp. Okay, so I'm down to 1 amp of current flowing in this circuit. Now, what if I added more resistors in? What if I added another 6 ohm resistor in there? So I put in another light bulb. Well, what would happen then? So if I put in another light bulb, that was 6. Okay, well, adding that in, now I'm going to have another 6 in there. And so this is going to be 18. Now I'm going to have 12 over 18. And what's going to happen to my current? Well, it's going to be less, right? 12 over 18 is 6 over 9, which is 2/3, which is 0.66. Okay, so my current has gone down because I added more resistors in. That makes sense, right? Makes a lot of sense. Okay. All right, let's take those same resistors, those light bulbs, and put them in a parallel circuit. Now, a parallel circuit has separate little branches. And the main advantage of that is, well, one of the advantages is that each one is basically across the light bulb. Each branch hooks on to where the light bulb is independently of the others. Okay, so they all hook on to the positive end of the battery. I'm sorry, I said light bulb. And they hook on to the negative end of the battery. Each one individually. Whereas a series circuit, they don't. This one doesn't hook right directly to the battery on either side. So in a series circuit, the light bulbs have to share the voltage. But in a parallel circuit, then what happens is they each get the full voltage. Okay, so each device operates independently. They each get their own voltage. They can also have their own switches. So they can each have a separate switch. You can turn one of the light bulbs off. It doesn't interrupt the flow of the others. And the total current in the branches add. So remember, for a series circuit, the resistors added. But for a parallel circuit, the currents add up. All right, so let's go see this in action. And here is a teacher who has hooked up to a 12-volt car battery, and he's got parallel circuits here, light bulbs, hooked onto these two main wires that are hooked to the terminals of the battery. That would make that a parallel circuit. Okay, so there are two different ways I'm going to show you to find the total current. One is to use determine the current in each branch using Ohm's law. And then you add those currents up. And that's one way I like to do it, because often as a physics student, I didn't just need to know the equivalent current or the equivalent resistance and stuff like that, as we'll learn. You needed to know what was going on in all the parts of the circuit. So this way I learned that pretty fast. Okay, so first of all, we're going to determine the current in each branch using Ohm's law. So I is going to be equal to V over R for each one, for each branch. And so I1 and R1. So let's put in some resistors. We use the same ones we used a few minutes ago, 2, 2, and 8. Then let's make this one. This is going to be R1. This is R2. And this is going to be R3. Okay, so I1 is going to be V, the total voltage, which is 12 volts still, divided by R1, which was 2 ohms. And so I'm going to get 6 amps. Now, I2 is also 2 ohms. So I don't have to recalculate that. I2 is also 6 ohms because, I'm sorry, 6 amps, because it was also 2 ohms. I3, though, is going to be the total voltage, 12 volts, over 8 ohms. So that's going to be 1.5 amps. Okay, so to find the total current now, I'm just going to add those currents up. All right, so 6 plus 6 plus 1.5. It'd help if things would write properly here. Keep having to make every line twice. So 6 plus 6 plus 1.5 is going to be 12, 13 and a half, right? 13.5 amps of current. Now, before we go off this, one thing is, that's a lot more current than we got in the other circuit, right? The series circuit, the resistors added up. They resisted the flow of the electricity. And so we only ended up with 1 amp at the end of that first calculation. Now, this one has 13.5 amps. Every light bulb is fully bright because it's receiving full current. Whereas this one, actually the light bulbs would be dimmer because they had to share that 12 volts spread amongst them all. And so because of sharing that 12 volts, they didn't actually get full voltage. So these would be much dimmer than the ones in the parallel circuit. So you can see some of the advantages to using a parallel circuit. All the devices get full voltage, and so they all are nice and bright. And at this point, it would be easy if I decide to add another resistor. I just do another calculation for I4 if I wanted to. Add in that 6 ohm resistor. Then that would be 12 volts over 6. That would be an additional 2 amps, and that would be very easy to add down here. Another 2 amps, and it would be 15.5, right? Okay, so it would be very easy to add on another calculation of our branch current at that point. Okay. The other method that people like to use is finding what's called an equivalent resistance. And to find an equivalent resistance, people, well, it used to be you had to be really good at fractions. Now you have to be really good at putting it in your calculator if you want, or good at fractions. So the equivalent resistance is this formula. 1 over the equivalent resistance is 1 over R1 plus 1 over R2 plus 1 over R3. So if I was going to find the equivalent resistance of those horrible numbers that I picked, I would have 1/2 plus 1/2 plus 1/8. And so now here's where the fun of being good at fractions comes in. Your least common multiple is 8, so I need that to be my denominator in each case. So I multiply top and bottom by 4, and so I would get 4 over 8 plus 4 over 8 plus 1 over 8, and that would be 9/8 if I did it correctly. Okay, so now that is my 1 over my equivalent resistance. Usually people mess up here. That's where they mess up, is they forget they have to turn it over. So my actual equivalent resistance is going to be 8/9. Okay, now that I've got that, I can use Ohm's law to find the current and put V over R equivalent. And so I've got 12 volts divided by 8/9. If I did it right. Doesn't seem like it's coming out to the right number here, but let's see. Okay, I'm going to use my calculator. 12 divided by 8, and then it's going to be multiplied by 9. It's 13.5. It worked. All right, so I got the same number of amps as I did on the previous page. I just did it a different way. Now, one problem with this is putting a branch, an additional bulb in. I would have to go back and recalculate my equivalent resistance. But otherwise, you know, some people really like to do it this way. Because then the series steps and the parallel steps are kind of the same. For the series circuit, it was add the resistors, find that equivalent resistance, use Ohm's law. And so some people like that. Now you can find an equivalent resistance and use Ohm's law. So same steps. But like I said, I'm rather fond of this method. Find the current in each branch, then add the currents. All right, and that's the end of that section. But here's a circuit that I believe might be in your homework. And what's going on? This is a combination of a parallel circuit and a series circuit. So this actually has 2 branches. So you have the current would be split into these two branches. And of course, it would come back together, which is how parallel circuits work, right? To get your total current. One of the branches has just one light bulb, and the other branch has a series of two light bulbs. So because these share the same voltage, if this was a 12-volt battery, this light bulb would be the brightest because it would have all 12 volts. Whereas these two light bulbs, if they were identical light bulbs, then they would have to share that 12 volts. So basically each one would get 6 volts. So they would be dimmer by quite a bit. Anyway, so that's circuits can be very complex, but these are the basis of the equations that you need for solving circuits. And of course, we don't have complex ones in this class. All right, and that's the end of part 3. We're going to go to the, no, that was the end of part 2, maybe. Okay, all right. All right, so let's stop this. All right.